A sheet of paper cannot slip between these ancient stone joints. This is the reality of precision-cut stones, a global phenomenon that challenges our entire timeline of human achievement. By the end of this journey, you will see history in a completely new light. How did cultures separated by oceans achieve such impossible perfection with only simple tools? What forgotten knowledge allowed them to carve and move mountains of stone? The answers force us to reconsider the very roots of civilization. What does it say about us that we still cannot fully explain the work of our ancestors? The sheer scale of the walls at Sacsayhuaman is humbling. You are looking at stones taller than a person, weighing as much as 200 tons, fitted together in a complex polygonal puzzle. The joints are so tight that after hundreds of years, not even a blade of grass can find space to grow between them. This was not simple stacking. Each irregular block, with its unique curves and angles, was painstakingly shaped to embrace the contours of the stones above, below, and beside it. The result is a monolithic structure that moves and breathes as one during the violent earthquakes that frequently shake the region. While the Inca are credited with its construction, the method remains one of history's great enigmas. Renowned engineer Jean-Pierre Protzen spent years studying the site. He proposed that workers pounded the stones against each other with harder rocks, a kind of trial and error process that slowly ground the surfaces into a perfect match. Yet, this theory struggles to explain the breathtaking consistency found across the entire fortress. How could such a chaotic, percussive method produce such flawless, seamless joins on such a massive scale and with such complex geometry? The time and labor required would have been astronomical, even for a society known for its monumental projects. This is not the work of simple hammer stones. It suggests a profound, perhaps lost, understanding of stone itself. The masons of Sacsayhuaman did not just build a wall. They engineered a living entity from the earth, a feat that continues to defy straightforward explanation and points toward a sophistication we are only beginning to appreciate. Deep beneath the sands of Egypt lies a different kind of precision, one not of interlocking puzzles but of impossible smoothness. The Serapeum of Saqqara is a labyrinth of tunnels, a silent, underground world housing 21 massive granite boxes. Each one is a sarcophagus carved from a single, solid block of stone weighing as much as 70 tons. But it is not their size that is most shocking, it is their finish. The interior surfaces are flawlessly flat and polished to a glass-like sheen. The corners where these flat planes meet are perfectly sharp, forming precise 90-degree angles that look as if they were cut by a modern machine. This is not the work of copper chisels and stone hammers, the tools we commonly associate with ancient Egypt. The stone they used is rose granite, one of the hardest stones on the planet. To even scratch its surface requires a material harder than itself. So how did they hollow out these immense blocks? How did they achieve such a mirror-like polish on the inside? The official explanation of pounding with dolerite balls and grinding with sand feels inadequate. Such methods might shape stone over generations, but they struggle to account for the machine tool precision evident in every corner and on every flat surface. When the French Egyptologist Auguste Mariette rediscovered these tombs in the 1850s, he was struck by their mystery. They were built to hold the sacred Apis bulls, but the method of their creation was already a forgotten art. The boxes show evidence of cutting techniques that suggest the use of massive, fixed saws and tubular drills capable of piercing solid granite. This implies a level of industrial manufacturing that simply does not fit our timeline. Were the ancient Egyptians privy to engineering secrets that were lost to time? a forgotten chapter in the story of human technology. This question pulls us from the deserts of Egypt across the ocean to a high plateau where another civilization performed its own stone-cutting miracles. High on the Bolivian Altiplano, the wind whips across a field of shattered stone giants. This is Puma Punku, and it looks less like a ruin and more like a cosmic factory floor after an explosion. Scattered across the barren landscape are H-shaped blocks, intricately carved slabs, and stone components of such bewildering complexity that they seem ripped from an engineering catalogue. These are not simple building blocks, they are pieces of a puzzle we have not yet learned how to solve. Each one is fashioned from andesite and red sandstone, materials notoriously difficult to work with. Yet their surfaces are flawlessly flat, their edges impossibly straight, and their faces are decorated with precisely cut notches, geometric channels, and perfectly circular drilled holes. They interlock with a concept that feels startlingly modern, as if they were designed to be part of a larger, modular assembly. The Tiwanaku culture, which thrived here over 1,000 years ago, is credited with its creation. But the sheer technical prowess on display seems to belong to a different age altogether. How do you achieve such a machined finish without machine tools? The andesite stone used here is only slightly softer than diamond. To carve it with such precision using simple stone hammers is nearly unthinkable. The geometric consistency across hundreds of broken pieces suggests the use of templates and standardized measuring systems, a concept of mass production that feels entirely out of place in the ancient world. Geologist Arthur Posnansky studied the site for decades, and the alignments of the remaining stones led him to propose a startlingly ancient origin, pushing the timeline back thousands of years before the Tiwanaku even existed. Whether his dating is accurate or not, the fundamental question remains. What tools could possibly have created these forms in an era we are told had no metal harder than copper and had not even invented the wheel? The stones of Puma Punku do not just ask us to reconsider a culture, they ask us to reconsider the entire technological capability of the ancient world. And this mystery only deepens when we examine the very substance they were working with. The challenge of Puma Punku is not just its design, but the very substance of its creation. Granite, diorite, and basalt are not ordinary rocks. They rank among the hardest materials on Earth, so tough that modern industry relies on diamond-tipped blades and high-powered machinery to cut them with any efficiency. Yet, we are told ancient artisans shaped these formidable stones with soft copper chisels, rounded stone hammers, and simple sand for abrasive powder. When modern experimenters try to use these methods, the results are telling. The process is agonizingly slow, and the work is messy and imprecise. For example, attempting to drill a hole in granite with a copper tube and wet sand does create a cut, but the hole is never clean. It is rough, tapered, and conical, showing clear signs of a crude grinding process. Now compare that to the artifacts actually found. At the Giza Plateau and other ancient sites, we find core samples drilled from solid granite that are perfectly cylindrical. The grooves cut into the stone are clean, even, and precise, as if made by a tool that bit into the rock with tremendous, consistent force. The evidence in the stone itself does not match the tools we have assigned to its creators. This glaring discrepancy has led forward-thinking engineers like Christopher Dunn to propose a radical idea. What if the ancient workers used advanced machinery? He and others point to the evidence, suggesting the use of ultrasonic drills that vibrate at incredible speeds or massive saws coated in diamond abrasive, technology we consider entirely modern. The immediate question is overwhelming. How could such sophisticated tools exist thousands of years ago? The stones themselves are the primary evidence, and they silently testify to a level of craftsmanship that forces a profound reevaluation. Perhaps our timeline is not wrong, but simply incomplete, missing a chapter where human ingenuity achieved a technological peak that was later forgotten, a thread we are only now beginning to pull. These foundation stones at Baalbek are not just large, they are incomprehensible. High on a platform in Lebanon rest 3 limestone blocks known as the Trilithon. Each one is a behemoth weighing roughly 800 tons, a weight comparable to 2 fully loaded jumbo jets. They were cut with such exacting flat surfaces and fitted together with such seamless joints that they have formed an unshakable foundation for thousands of years. Yet the true magnitude of the achievement lies not just on the platform, but in the quarry nearly a full mile away. There, still partially attached to the bedrock, lies the stone of the pregnant woman. This single block of stone is estimated to weigh over 1,000 tons, making it one of the largest pieces of stone ever carved by human hands. The Romans, who built their grand temple of Jupiter upon this base, are often given the credit. But why would Roman engineers go to the extreme of quarrying and moving a 1,000-ton block when their own renowned architecture never required such staggering scale elsewhere? The style and the sheer, almost unnecessary, ambition of these foundation stones suggest they may have been the work of a far more ancient culture, a civilization that mastered megalithic engineering long before the Romans ever arrived. This forces a logistical question that echoes through the ages. How do you move a mountain? The quarry was situated on a slope lower than the building site. This means these 800-ton blocks were not simply rolled downhill. They had to be lifted and transported up an incline, a feat that seems to defy the capabilities of any known ancient technology. Theories of wooden rollers, massive levers, and armies of men and oxen have been proposed, but they all strain under the immense physical reality. Wooden rollers would have splintered into dust under such concentrated weight. Coordinating thousands of workers to pull a single block without catastrophic missteps would have been a miracle of organization in itself. The precision of the placement is the final, baffling piece of the puzzle. It is one thing to drag a giant stone. It is another to gently lower it into a position so precise that it locks perfectly with its neighbors, creating a foundation that has withstood earthquakes and empires. This was not brute force. This was a symphony of engineering, a lost art of moving the earth itself. Perhaps the most compelling clue is not in the tools we can see, but in the tools we can hear. A radical theory suggests that ancient builders mastered the use of sound frequencies to manipulate stone itself. Researchers like John Stuart Reid have explored the science of cymatics, which reveals how specific vibrations can shape and organize matter. In experiments, sound waves directed at a plate of sand cause the grains to form intricate geometric patterns, a visible demonstration of invisible energy shaping a physical material. Could the same principle have been applied on a monumental scale? Some point to enigmatic artifacts like the Egyptian Djed pillar, a symbol of stability, and propose it may have been more than symbolic. It could have functioned as a resonant chamber, a sonic device capable of focusing acoustic energy. At the mysterious Osirian in Abydos, a structure built with cyclopean blocks of granite, the precision of the stonework is so extreme that it has fueled speculation about resonant frequencies being used to temporarily alter the state of the stone, making it malleable, almost like a liquid for easier shaping and placement. While this idea currently sits on the fringe of archaeology and lacks definitive proof, it is not without its echoes in tradition. Indigenous accounts from various cultures speak of ancestors who used chants and songs to make stones light enough to float into place. The theory of acoustic softening provides a potential, though highly speculative, answer to the central question of how these stones were cut and fitted with such impossible perfection. It suggests a forgotten branch of physics, a lost technology that used vibration as a tool. If sound was the missing piece of the artisan's kit, it forces us to reconsider everything we thought we knew about the past, moving from the realm of solid tools into the invisible world of energy. But what if the stones themselves are not what they seem? Imagine a world where the most perfect stone blocks were not dragged from distant quarries, but were instead poured into place like modern concrete. This is the radical proposal of materials scientist Joseph Davidovits, known as the geopolymer theory. He suggests that the ancient Egyptians did not need to cut and move impossibly heavy stones. Instead, they could have manufactured them directly on the building site. The process would have involved taking the soft, natural limestone that is abundant in the area, crushing it into a fine powder, and then mixing it with a special alkaline activator, a substance like natron salt, which was readily available to them. This chemical reaction would create a kind of synthetic stone slurry, a primitive but effective geopolymer concrete, which could then be poured into wooden molds. Once it hardened, the result would be a block of reconstituted limestone that was chemically identical to natural stone, but could be formed with flawless precision. This single idea could neatly explain so many of the mysteries. It accounts for the impossibly tight joints, the complete absence of tool marks on many surfaces, and the incredible uniformity of the blocks. The entire construction process would be transformed from a brutal feat of logistics into a sophisticated chemical engineering project. Of course, the theory has its critics. They point to the presence of natural fossil shells found within the pyramid blocks, arguing that these biological signatures could not survive the high heat and chemical process of creating a geopolymer. Davidovits counters that a low-temperature reaction could indeed preserve such fossils, and that the specific mineral composition of the stones points toward a man-made origin. Whether the theory is ultimately proven correct or not, its very existence is a powerful challenge. It forces us to ask a profound question. Did ancient civilizations possess a deep, almost alchemical knowledge of their materials, a science of stone that we have completely overlooked? This shifts the entire mystery from one of physical engineering to one of chemical mastery, suggesting a forgotten branch of ancient technology that was not based on force but on formula. The mystery of precision stonework is not locked away in a distant past. In the humid air of 20th century Florida, one man performed a modern miracle that echoes the ancient enigmas. Edward Leedskalnin, a frail Latvian immigrant barely 5 feet tall and weighing just 100 pounds, single-handedly built Coral Castle. Over 28 years, he quarried, carved, and positioned over 1,000 tons of massive coral block, all in secret under the cover of night. He worked alone, using tools he fashioned from old car parts and scavenged metal. The central puzzle is as immense as the stones themselves. How could one man, without modern machinery or even assistance, manipulate blocks weighing up to 30 tons? Leedskalnin himself offered cryptic clues, claiming he had rediscovered the building secrets of the ancient Egyptians, the very same secrets that raised the pyramids. He spoke of understanding the laws of weight and leverage, and of using what he called perpetual motion holders. He never elaborated, and the true method died with him. The results, however, speak volumes. Among his creations is a 9-ton stone gate, perfectly balanced on a simple truck axle. It is so exquisitely poised that even a child can push it open with a single finger, a feat of engineering that continues to baffle visitors and experts alike. This precise balance has fueled endless speculation. Did Leedskalnin uncover a way to manipulate magnetic fields or even negate gravity? He was known to conduct experiments with magnets and spoke of the cosmic forces within coral rock. While mainstream science remains skeptical, the physical evidence at Coral Castle is undeniable. It stands as a stubborn, modern testament that the ability to work stone with impossible precision may not be entirely lost but merely forgotten. This one man's lifelong project creates a direct bridge from the ancient world to our own, forcing us to ask what other fragments of profound knowledge might have slipped through the cracks of history, waiting to be rediscovered. These stones were not merely placed for structural strength. They were positioned as points on a vast celestial map. Across the globe, the greatest megalithic sites function as sophisticated astronomical observatories, their precision-cut blocks aligned with the sun, moon, and stars with an accuracy that defies their supposed antiquity. High in the Andes, the Intihuatana stone at Machu Picchu is a masterpiece of carved granite. Its angles and protrusions are not random. They were designed to precisely capture the sun's rays during the solstices and equinoxes, casting specific shadows that marked the changing seasons for the Inca. This was a stone calendar, a way of anchoring their world to the cycles of the cosmos. An even more profound alignment exists at the Great Pyramid of Giza. Its base is almost a perfect square, and its four sides are oriented to the four cardinal directions with a deviation of less than 1/15 of a single degree. To achieve this level of accuracy with such a massive structure is an engineering marvel that modern surveyors would find challenging even with laser technology. This was not a lucky guess. It demonstrates a deep, foundational knowledge of spherical astronomy and geometry, the kind of knowledge that typically requires centuries of accumulated observation. So what does this tell us about the builders? Their primary goal seems to have transcended mere shelter or even royal tombs. They were integrating their world with the universe, encoding cosmic laws into the very bedrock. Researchers like Graham Hancock propose that this shared, high-precision astronomy points to a common source, a forgotten mother culture that possessed this advanced knowledge long before the rise of known civilizations. Whether one agrees with that theory or not, the alignment evidence forces a simple, powerful conclusion. The people who cut these stones were not just master masons. They were master astronomers. Their work reveals a priority that goes far beyond the physical, suggesting a civilization that measured its success not just by the walls it built, but by its harmony with the heavens. This celestial ambition brings us to the ultimate puzzle, the very instruments that made such perfection possible. The evidence is literally carved in stone, waiting in plain sight within the quarries and temples of Egypt. At the Temple of Hathor in Dendera, a broken granite core tells a story that shatters conventional history. This cylindrical piece of stone, a leftover from an ancient drilling process, is covered in a continuous, uniform spiral groove. The cut is clean and deep, and it maintains a perfectly consistent pitch from one end to the other. This is not the jagged, irregular mark of a hand-powered drill. A man turning a drill by hand would inevitably slow down, speed up, or change pressure, leaving a variable, uneven pattern in the stone. The groove on this core suggests a drill that applied immense, constant pressure and rotated at a steady, unvarying speed, a feat only achievable by a machine. The implications are staggering. Engineer Christopher Dunn, after meticulous analysis, calculated that the drill responsible would have needed to feed into the granite at a rate of almost 1 millimeter per revolution of the drill bit. This is an industrial level of precision. The ancient workers were not just carving stone, they were machining it. The same story is told by the saw marks left on immense blocks of basalt, another brutally hard stone. The cuts are perfectly straight and parallel, showing no sign of the wandering or wavering that would come from a manual saw being pushed back and forth by human hands. The clean, efficient nature of these cuts suggests the use of a saw blade studded with an abrasive harder than the stone itself, possibly diamonds, mounted on a stable, mechanical apparatus. This forces a monumental question: how did they power such devices? We assume they had no electricity, no steam engines, but what if our assumption is wrong? Perhaps they harnessed a different kind of power entirely. The sheer scale of their machining projects hints at an energy source that was both abundant and sophisticated. Could they have used hydraulic power from the Nile, or massive counterweight systems, or even mechanical power derived from something as simple as a falling weight? The stones do not tell us what powered the tools, only that the tools themselves existed. This silent testimony points toward a technological landscape in ancient Egypt that was far more advanced and far more mechanical than any history book has ever dared to describe. The evidence at Göbekli Tepe is a profound anomaly in human history. This vast complex of carved stone circles in Turkey was deliberately buried around 12,000 years ago, a time when, according to conventional history, humans were simple hunter-gatherers. Yet the pillars erected here are monumental, decorated with exquisite carvings of animals and abstract symbols. The stonework displays a level of planning and skill that should not exist in that era. There is no evidence of a gradual development of these abilities, no crude prototypes found nearby. The site appears fully formed, as if the knowledge to build it arrived already perfected. This sudden emergence of sophistication is exactly what fuels the theory of a lost mother culture, a civilization advanced enough to seed such knowledge across the world before vanishing beneath rising seas or climatic shifts. Authors like Graham Hancock argue that the precision stonework we see from Peru to Egypt is not a case of independent invention, but the legacy of this common source. The global flood myths found in countless cultures could be distant, garbled memories of a real cataclysm that shattered this advanced world. The survivors, scattered and isolated, would have carried fragments of their former knowledge, which eventually manifested in the incredible, yet declining, megalithic sites we study today. This idea provides a compelling, if controversial, explanation for the technological gaps. It suggests that human civilization is not a straight line of progress, but a cycle of rise and catastrophic fall. Of course, mainstream archaeology pushes back forcefully. The primary counter-argument is a simple, powerful one. Where is the evidence? If such an advanced global civilization existed, where are its cities, its tools, its trash heaps? We have found endless artifacts from ancient Sumer and Egypt, but nothing conclusive from this proposed precursor. Skeptics suggest that Göbekli Tepe itself is not proof of a lost civilization, but rather proof that our ancestors were far more capable and organized than we ever gave them credit for. They propose that complex society could have arisen from hunter-gatherer groups coming together for seasonal rituals, slowly developing these skills over generations we have yet to fully uncover. This debate forces us to confront the very nature of history itself. Is the absence of evidence truly evidence of absence, especially when searching for a civilization drowned by rising oceans over 10,000 years ago? A possibility remains hanging over these ancient stones like a ghost. Whether you find the lost civilization theory convincing or not, its value is undeniable. It challenges us to look at the archaeological record with fresh eyes and to ask harder questions. What if our story is much older and much more incredible than we have ever allowed ourselves to believe? This line of inquiry does not end with sunken continents, but pulls us toward a more tangible and perhaps more unsettling possibility. What if the knowledge was not entirely lost, but was deliberately hidden or encoded for a future generation to discover? Beneath the waves off Japan's Yonaguni Island lies a structure that challenges the very divide between nature and human art. In the 1980s, a local diver named Kyokairo Aratake was exploring these clear waters when he stumbled upon a site that would ignite a fierce scientific debate. Rising from the seabed is a massive formation of sandstone, a complex of terraces, wide steps, and towering walls that meet at sharp, seemingly precise 90-degree angles. Some of its faces are perfectly flat, while others feature what look like carved channels and what can only be described as a triangular entranceway. The entire complex is colossal, stretching for hundreds of feet, a sunken citadel sleeping in the deep. On one side of the debate are geologists who point to the region's unique sandstone, which naturally fractures along straight lines and flat plains due to intense tectonic activity. They argue that the powerful currents and relentless erosion could have sculpted these remarkably geometric shapes entirely by chance, a fantastic but natural work of art. Yet other researchers, led by marine geologist Masaaki Kimura, have spent years studying the site and argue that nature alone cannot explain the full picture. They highlight the two perfectly round holes found next to one of the terraces, holes that look uncannily like post holes drilled to hold a structure. They point to the long, straight row of smaller stones that resembles a carefully laid road. Most compellingly, they note the sheer concentration of so many right angles and symmetrical features in a single, cohesive formation. If this is all a natural coincidence, it is a statistical marvel on an epic scale. The implications of a human origin are staggering. For the Yonaguni Monument to have been built or even modified by people, it had to have been on dry land. The last time this area was above water was at the end of the last ice age, over 10,000 years ago. This timeline pushes the origins of complex stoneworking back thousands of years before the pyramids of Egypt or the stones of Göbekli Tepe were erected. This underwater enigma forces us to add a new dimension to our investigation, the dimension of climate change and rising seas. It suggests that the most telling evidence of a lost chapter in human history may not be buried in desert sands, but submerged beneath the ocean, waiting for us to rediscover it. The drive to fit stones with such impossible perfection was about far more than just engineering. For these ancient cultures, the very act of creating seamless stonework was a spiritual endeavor, a physical prayer carved into the earth. The Inca saw their polygonal walls as a reflection of their own social fabric. Each uniquely shaped block, locked immovably with its neighbors, was a powerful symbol of community and interdependence. The wall's strength came from the unity of its diverse parts, a metaphor for an empire built from many different peoples, all bound together into an unshakable whole. This was not just construction, it was a statement of ideology in stone, a declaration that their civilization would endure as permanently as the mountains themselves. In Egypt, this obsession with precision was rooted in the concept of Ma'at, the fundamental principle of cosmic order, truth, and balance. The universe, they believed, was a delicate equilibrium that had to be constantly maintained against the forces of chaos. A pyramid was not merely a tomb, it was a machine for eternity, an instrument to ensure the pharaoh's successful journey to the afterlife, and by extension, the continued stability of the entire kingdom. Any imperfection, any misaligned joint or uneven surface was a crack in the fabric of Ma'at. It was an invitation to chaos. Therefore, the flawless geometry of their structures was a moral and religious imperative. The gods demanded perfection because perfection was order, and order was the foundation of existence. This profound symbolic drive may well have been the catalyst for the very technological leaps that baffle us today. When your culture's spiritual survival depends on achieving perfect 90-degree angles and mirror-smooth surfaces, you do not settle for good enough. You innovate, you push the boundaries of what is possible with the materials you have. The desire to please the gods or embody a cosmic principle could have fueled centuries of experimentation, leading to the development of advanced drilling and sawing techniques that we struggle to replicate. The why behind these stones reveals a crucial truth about human ingenuity. It is often our deepest beliefs, our most profound questions about the universe and our place within it, that propel technology forward. We are at our most inventive not when we are merely solving practical problems, but when we are striving to touch the divine. This cultural context transforms the mystery from a simple "how did they do it" to a more profound "why did they need to do it so perfectly?" And that understanding of their motivation brings us face to face with the final, practical challenge that stands between us and the truth. Isolated in the vast expanse of the Pacific Ocean, Easter Island stands as a testament to a different kind of precision, one carved not into walls but into the faces of giants. Here, the Rapa Nui people created the moe, nearly 900 colossal statues gazing inland from their stone platforms. These were not crude idols. They were masterworks of volcanic tuff, quarried from the slopes of the Rano-Raraku volcano with an astonishing level of detail. The features are sharp and distinct, from strong brows and elongated ears to carefully sculpted nostrils, and most tellingly, deep eye sockets designed to hold inlaid eyes of white coral and obsidian. The sheer scale of the operation is breathtaking. Some of these figures stand over 30 feet tall and weigh more than 80 tons. And as if that were not enough, many were later crowned with massive cylinders of red scoria stone called Punku, each one a staggering topknot weighing up to 12 tons. How did a community that likely never exceeded a few thousand people, on an island with no large trees or metal resources, achieve such a feat? The classic experiment of wrapping ropes around a replica statue and rocking it side to side with a team of people demonstrated that movement was possible. It showed that with enough coordinated labor and rope made from island shrubs, a moe could be walked along a path. Yet, this practical demonstration does not fully account for the finesse. The transportation of the multi-ton Punku hats presents an even greater puzzle. How were these cumbersome cylinders lifted and precisely balanced atop the towering heads? The journey from quarry to final platform was a gauntlet of logistical nightmares, demanding not just brute force but an intimate understanding of balance, leverage, and the island's challenging terrain. This was more than a construction project. It was an act of profound cultural expression, a society channeling its entire identity into the creation of stone ancestors. The Rapa Nui did not just move rock, they moved mountains of it, driven by a belief system that compelled them to achieve the monumental with the most minimal of tools. Their story echoes a universal theme we have seen from Peru to Egypt. It reveals a fundamental truth about humanity. When our spirit is moved to create, we find a way to bend stone to our will, leaving behind legacies that continue to whisper across the centuries. The Egyptians and the Incas worked with different materials on different continents, yet both solved the same engineering puzzle. In Egypt, the challenge was granite, a brutally hard stone. Their solution, as best we understand it, was a patient grinding process using copper saws and drills fed with a slurry of abrasive sand. This method was subtractive, wearing the stone away bit by tiny bit. Across the ocean, the Inca faced andesite, another incredibly tough material. Their approach was more sculptural, using hammerstones to pound the surfaces, effectively pecking and grinding the stone into its final, interlocking form. One culture used metal tools with abrasives, the other used harder stones to shape stone. Yet both arrived at the same breathtaking result, walls where the joints vanish. This pattern of divergent methods leading to convergent perfection appears again in Mycenaean Greece. At sites like Mycenae and Tiryns, massive limestone blocks are fitted together with such precision that the walls are known as Cyclopean, built by giants. The joint style is different, often larger and more linear than the Inca's polygonal puzzle, but the underlying principle is identical. Immense stones cut to lock together so perfectly that they have stood for millennia without a drop of mortar. This cross-cultural analysis is deeply revealing. It shows us that there was no single, secret instruction manual passed from one master builder to another. Instead, it points to a powerful, universal human drive to build things that last. Different cultures, facing the same fundamental problems of physics and material science, independently discovered different paths to the same summit of achievement. This tells us that the core knowledge, the understanding of geometry, stress distribution, and material properties, was not necessarily a shared secret, but a logical endpoint of intense, localized innovation. The real mystery then shifts. It is not that one civilization knew a magic trick the others did not. It is that so many, in isolation, developed the sheer persistence and intellectual rigor to master stone at this level. This realization sets the stage for our final, modern challenge. If they could do it with what we assume were simple tools, can we prove it by replicating their work today? Modern experiments to rebuild the past often reveal more about our ignorance than our knowledge. Archaeologists and skilled stonemasons have gathered at sites around the world, armed with the tools we believe the ancients used. They swing dolerite pounders against granite. They drag copper saws back and forth with loads of sand and water. The process works in a rudimentary sense. Stone is indeed cut, blocks are shaped, but the results are consistently, undeniably crude. The edges are uneven, the surfaces are rough and pitted, and the entire endeavor is agonizingly slow. A team might spend weeks producing a single, imperfect block, a far cry from the thousands of immaculate stones that form the Great Pyramid. The celebrated project led by Mark Lehner at the Giza Plateau demonstrated that copper saws with quartz sand abrasive can cut through the local limestone. Yet even this success story highlights a deeper puzzle. The local limestone is relatively soft, and the saw marks left in the experiments are messy and wandering, nothing like the clean, efficient cuts sometimes found on ancient basalt or granite. The experimental methods struggle to explain the finer details, the flawless 90-degree angles inside the Serapeum boxes, or the machined flatness of the stones at Puma, Punku. So why does our best modern replication, using the tools we assigned to them, fall so dramatically short of the original work? This gap between theory and practice is where the real mystery lies. It forces a humbling conclusion. Perhaps we are not just missing a tool, but an entire technique. Maybe the ancients possessed a nuanced understanding of the process, a specific rhythm or a forgotten trick that transformed a crude grinding action into a precise cutting method. Could it be a particular type of sand, a specific water to abrasive ratio, or a way of mounting the tool that we have never considered? These hands-on attempts do not close the case. They blow it wide open, proving that the true ingredient we lack is not brawn, but the sophisticated knowledge that turned labor into an art form. Some theories leap from the pages of history into the stars themselves. When faced with a mystery as profound as these stones, a certain line of thought suggests the builders must have had help from beyond our world. Authors like Erich von Däniken became famous for proposing that ancient sites are the work of extraterrestrial visitors, beings who shared advanced technology with primitive humans. The argument often hinges on the sheer, almost inhuman, scale and accuracy of the pyramids or Puma Punku. How could humans, the theory asks, have aligned the Great Pyramid to true north with such stunning precision without laser guidance from the sky? Why do so many cultures have myths of gods descending from the heavens, if not as a distorted memory of these encounters? For many, this ancient astronaut hypothesis provides a thrillingly simple answer to a deeply complex question. Mainstream archaeology, however, dismisses this idea almost entirely. Scholars point out that this theory often relies on a profound underestimation of ancient human ingenuity, effectively robbing our ancestors of their most spectacular achievements. It creates a narrative where humans were merely passive recipients of alien knowledge, rather than the active, brilliant innovators that the archaeological record proves them to be. Yet, this is not the only form of supernatural explanation. Look at the local legends that have sprung up around these sites. The massive walls of Mycenae were said by the later Greeks to have been built by the Cyclopes, a race of one-eyed giants. The Inca had stories of their founders possessing a divine power that could make stones soften and move at their command. These are not claims of alien visitation, but a different kind of answer, one rooted in the belief that the distant past was an age of miracles when gods and giants walked the earth and performed impossible feats. While neither ancient aliens nor divine giants hold up to scientific scrutiny, their enduring popularity tells us something crucial about ourselves. They are a testament to the sheer awe these structures inspire and to a very human need to explain the extraordinary. When we stand before a wall where a sheet of paper cannot slip between the stones, our modern, rational minds can struggle to process it. So we reach for the supernatural or the extraterrestrial to bridge the gap in our understanding. These narratives, in their own way, highlight the very real and unresolved nature of the mystery. They force us to ask a difficult question. Does our search for a rational explanation become biased by our own technological pride? Are we perhaps too quick to dismiss any theory that suggests ancient cultures might have developed a science that looked nothing like our own? A path of technology that was lost and remains unfamiliar to us. The value of these controversial ideas is not in their factual accuracy, but in the perspective they offer. They remind us to keep our minds open to possibilities, even as we keep our feet firmly planted on the ground of evidence. The very stone itself held secrets the builders learned to unlock. Across the globe, ancient artisans did not fight their materials, they collaborated with them, turning geological quirks into technological advantages. Take the andesite at Puma Punku. When first extracted from the quarry, this incredibly hard rock contains a higher level of natural moisture, making it slightly softer and more malleable. This would have given the masons a critical window of opportunity. A few precious days or weeks to carve the intricate channels and perfect flat surfaces with greater ease. Once the stone was exposed to the air and sun, it would dehydrate and harden into its final, diamond-like state, permanently preserving that flawless finish. This was not magic, it was a profound understanding of material science, a scheduled race against time written in the rock's very nature. In Egypt, the massive limestone blocks of the Giza Plateau presented a different kind of gift. Limestone forms in sedimentary layers, and the builders exploited this natural bedding plane. By inserting wooden wedges into natural fissures and then soaking the wood with water, they could use the tremendous force of expansion to split the stone cleanly along its weakest line. This method required far less brute force than pounding the stone apart, and it provided them with relatively flat starting slabs. The environment offered other clever tricks. In desert regions, the extreme temperature shift from scorching day to freezing night causes rock to expand and contract. Strategic fires built on a rock face, followed by a rapid dousing with cold water, could generate enough thermal shock to create deep fractures, effectively quarrying the stone with little more than heat and patience. This geological perspective does not diminish the achievement, it refines it. It reveals a deep, observant relationship between the builders and their world. They were not just masters of geometry, they were practical geologists who knew how to read the landscape. They listened to the stone, understood its cycles, and used its inherent properties as part of their toolkit. This practical wisdom connects the grand mystery directly to the earth, suggesting that the true secret was not a single advanced tool, but a cultivated, generational intelligence applied to the resources at hand. Deep in the lush river deltas of Costa Rica, another form of ancient perfection lies half buried in the earth. Scattered across the landscape are hundreds of stone spheres, some small enough to hold in your hand, others standing taller than a person. Crafted by pre-Columbian cultures over 1,000 years ago, these enigmatic balls of gabbro and limestone achieve a near-perfect roundness that seems to defy their handmade origins. Their surfaces are unnervingly smooth, their curves impeccably even. While archaeologists propose a method of patient pecking and grinding with other stones, this does little to explain the breathtaking consistency. How could artisans working over centuries maintain such a strict geometric standard without a master template or a universal unit of measure? The creation process itself remains a puzzle. Workers would have first selected a large boulder, then painstakingly shaped it by striking it with hammerstones of a harder material, gradually knocking away the rough exterior. The final stage likely involved grinding the sphere with sand and water to achieve its signature smoothness. Yet the mental image of craftsmen slowly walking around a multi-ton stone, judging its curvature by eye alone, is difficult to reconcile with the flawless results. The sheer number of these spheres and their uniformity suggests a deeply embedded tradition and a rigorously controlled technique passed down through generations. Their purpose is just as mysterious. Some theories propose they were astronomical markers arranged to mirror constellations. Others believe they were status symbols placed near the homes of chiefs to denote power and authority. A few spheres have been found arranged in alignments, perhaps forming a celestial calendar or a map of sacred geography. Unlike the immense walls of Sacsayhuamon or the boxes of the Serapeum, these were not part of a grand structure. Their precision was an end in itself, a standalone expression of geometric idealism. This reveals that the drive for perfection was not confined to architecture. It could be poured into a single, portable object, a testament to a culture that valued abstract form and symbolic meaning carved in stone. The spheres of Costa Rica expand the mystery beyond buildings, showing us that ancient precision was a versatile art, one that could be as concentrated and profound as a perfect circle resting silently in the jungle. The stones themselves are a kind of frozen mathematics. Beyond the physical joints and polished surfaces lies a hidden layer of precision, one written in the universal language of geometry and number. The Great Pyramid of Giza is perhaps the ultimate example, a structure whose very proportions seem to encode complex mathematical truths. The ratio of its perimeter to its height is remarkably close to 2 times pi, the fundamental constant of a circle. This is no coincidence. It suggests the builders conceived of a design that harmonized linear and circular geometry in a single, monumental form. Some analyses go even further, proposing that the pyramid's dimensions scale down the northern hemisphere of the Earth itself, with its perimeter corresponding to the equatorial circumference at a specific, reduced scale. This is not simple tomb building, it is global cartography rendered in limestone. Researchers like Robert Bovell have spent decades unraveling these connections, arguing that the entire Giza Plateau is a terrestrial map of the Orion constellation, a belief system literally set in stone. How could a civilization without advanced measuring devices achieve such staggering accuracy? The answer may lie in a deep, intuitive grasp of applied mathematics. The Pythagorean theorem, which defines the relationship between the sides of a right triangle, was known to these ancient architects long before the Greek philosopher was born. They would have used simple but powerful tools like knotted ropes, which could be stretched into perfect 3, 4, 5 triangles to ensure right angles for their foundations. This was not abstract theory, it was practical knowledge for aligning vast constructions to the cardinal directions with an error of less than a fraction of a single degree. The transmission of this knowledge was the true lifeblood of their civilization. A master mason would not merely teach an apprentice how to swing a hammer. He would instill in him a lifelong understanding of sacred ratios, the seasonal movements of the stars, and the geometric principles that turn a pile of rocks into an eternal statement. This was a living tradition, an unbroken chain of intellectual inheritance where the secrets of the universe were passed down through generations of careful observation and disciplined practice. The perfection we see today is the final exam of countless forgotten students, a testament to an educational system that valued cosmic harmony as much as it did physical skill. This chain of knowledge was the true mortar that held ancient engineering together. Behind every impossibly tight joint and every perfectly angled stone stood a master artisan, and beside him an apprentice learning by doing. This was not a classroom with textbooks, but a lifelong immersion in craft, where the secrets of stone were passed down through touch, sight, and relentless practice. In medieval Europe, stonemason guilds were the guardians of this hidden curriculum. A young apprentice would spend years performing the most basic tasks, simply observing the masters at work before ever being trusted to shape a critical block. The most powerful techniques, the precise angles for complex joints or the secret mixtures for effective abrasives, were closely held secrets, shared only with those who had proven their dedication. This system of master to apprentice created an unbroken lineage of skill, but it was also incredibly fragile. The knowledge lived in the hands and minds of a select few. The master artisans of the Inca Empire likely operated under a similar principle. Their methods for shaping andesite were not written down, but were refined over generations through endless trial and error. A father would teach his son the exact sound a hammerstone makes when the angle is correct, or the subtle visual cue that signals a surface is finally flat. This deeply embedded, tactile wisdom allowed for the creation of Sacsayhuaman's walls, but it also meant that the entire methodology was vulnerable. When a civilization fractures, when conquest or disease disrupts this delicate teacher-student chain, the knowledge can vanish in a single generation. The Spanish conquest of the Inca is a stark example. The societal structures that supported these specialized artisans were dismantled. The masters died, and their apprentices were scattered or forced into new ways of life. The intricate, hands-on education that produced such stonework simply stopped. This explains why these techniques did not spread or survive. They were not ideas that could be easily written in a book, but living traditions that required a stable, supportive culture to nurture them across centuries. The loss of this secret knowledge forces us to ask a difficult question about our own time. In an age of digital data and instant access, have we forgotten the irreplaceable value of the slow, patient transfer of wisdom from one pair of hands to another? The silence of the stones is a testament to the profound fragility of human knowledge itself. A city rises from a shallow lagoon, a silent maze of canals and crumbling walls. This is Madol, a forgotten capital built not on solid ground, but atop nearly 100 artificial islets off the coast of Pohnpei. Its foundations are colossal logs of basalt, some weighing 50 tons, meticulously stacked in crisscross patterns to form formidable barriers against the relentless sea. Each prismatic column was quarried from the opposite side of the island, then transported through treacherous mangrove channels and open water to this sacred site. The scale of the labor is almost incomprehensible. The Sordelor dynasty ruled here for centuries, yet they left behind no written records, no diagrams explaining how they achieved this logistical miracle. Local legends fill the void with tales of two powerful sorcerers who used magic to levitate the stones through the air, commanding them to fly to their designated places. While we dismiss the literal interpretation of flying stones, these stories preserve a core truth that the methods used were so extraordinary they seemed supernatural to those who came after. The practical reality was likely a breathtaking feat of coordinated effort. Imagine fleets of outrigger canoes lashed together into massive rafts, carefully ferrying these stone giants across the water. The builders may have used the tides to their advantage, floating the stones at high tide to position them directly onto the growing walls. The precision of the crisscross stacking is its own kind of engineering magic, a deliberate design that created immense stability, allowing the walls to withstand centuries of tropical storms and tidal forces. How does this remote oceanic complex fit into our global puzzle? Nan Madol stands as a powerful reminder that the drive to achieve the impossible in stone was not confined to deserts or mountain peaks. It flourished in isolation on a tiny Pacific island, proving that this was a fundamental human impulse. The Sordelors, like the Inca and the Egyptians, possessed a sophisticated understanding of their environment, leveraging water, gravity, and sheer human will to bend the landscape to their vision. The true tragedy of Nan Madol and so many other sites is what happened when that chain of knowledge was shattered. With the fall of the Sordelors, the precise techniques for moving and stacking these basalt logs vanished into the jungle and the sea, leaving behind only the silent, staggering stones and the echo of legends. The arrival of colonizers did more than just conquer lands. It severed the living thread of knowledge. In the Andes, the Spanish systematically dismantled the Inca social order, a hierarchy that had supported the master masons responsible for the impossible stonework at Machu Picchu and Sacsayhuaman. These artisans were not merely laborers, they were the guardians of a profound, tactile science passed down through generations. With their society shattered, these masters died without apprentices, and their intricate understanding of stone vibration, precise pounding, and interlocking geometry vanished into silence. The same tragic pattern unfolded across the Americas. The Maya, whose own precise corbelled arches and astronomical alignments rival any in the world, saw their written records burned by missionaries as works of the devil. Countless codices, which may have held the keys to their construction techniques and mathematical principles, were lost forever in the flames. This was not merely a change in leadership, it was a targeted erasure of an entire intellectual tradition. The surviving populations were often forced into new economic systems, their specialized roles replaced by the demands of their new rulers. The skill to fit stones so perfectly that they move as one during an earthquake became not just obsolete but forgotten. This historical context fundamentally alters our search for answers. We are not simply piecing together an ancient puzzle, we are trying to reconstruct a picture where half the pieces were deliberately burned. The exact techniques, the nuanced tricks of the trade that transformed back-breaking labor into an art form, are likely gone for good. They existed in the muscle memory of a craftsman, in the specific chant used to set a rhythm for pounding, in the oral traditions that explained which quarry produced stone that was easier to work when wet. This profound loss forces a humbling realization. Our inability to replicate their work perfectly today is not necessarily a failure of our modern intellect or tools. It is a consequence of a catastrophic break in human knowledge. Acknowledging this encourages a more respectful approach. It means valuing the remaining cultural heritage not as a mystery to be solved, but as a sacred fragment of a much larger, vanished whole. It shifts our focus from simply asking how they did it, to asking what we must do to ensure that the precious knowledge we still possess is never lost again. A botanical secret might have been the ancient mason's most powerful tool. The theory of plant-based softeners proposes that builders discovered natural chemicals that could temporarily alter the surface of stone, making it pliable for carving. Imagine a thick paste made from the leaves of sorrel, a common plant rich in oxalic acid, slathered onto a limestone block. This acidic substance could have chewed away at the crystalline structure of the rock, effectively softening its outer layer just enough to allow for precise shaping with simple tools. Proponents of this idea point to the very specific flora found in regions known for megalithic construction, plants that indigenous cultures have used for centuries in traditional medicine and dyeing, processes that require a deep understanding of chemical reactions. The knowledge of which plant to use, how to prepare the extract, and the exact duration of application would have been a guarded secret, passed from master to apprentice. Modern experiments have indeed shown that certain organic acids can etch and weaken stone surfaces. Yet, these contemporary attempts consistently fail to replicate the flawless, machine-like precision seen in the granite boxes of the Serapeum or the intricate channels at Puma Punku. The chemical reaction tends to be imprecise, often leaving the stone pitted and uneven, a far cry from the mirror-smooth finishes of the ancients. If this was their method, it was not a simple matter of applying a juice and watching the stone melt. It would have required an alchemical-level understanding of concentrations, exposure times, and neutralization processes to stop the reaction at the perfect moment. This transforms the image of the ancient builder from a brute laborer into a sophisticated chemist, a person who understood the molecular language of the earth itself. The question then becomes not just what plant they used, but what intricate multi-step recipe they followed, a formula that has since evaporated from history. Beneath the iconic pyramids, a second, hidden world of precision lies in near-total darkness. While the Sphinx guards the sands above, a labyrinth of tunnels and chambers extends deep into the bedrock of the Giza Plateau. Among the most enigmatic is the so-called Tomb of Osiris, a multi-level complex discovered in a flooded shaft. Descending into this subterranean structure is like entering a different kind of pyramid, one built inward instead of upward. Its walls are fashioned from massive blocks of granite and basalt, cut with the same flawless surfaces and sharp corners found in the most sacred temples above ground. The layout is a geometric puzzle with pillars, niches, and empty sarcophagi arranged in a pattern that feels both ceremonial and strangely industrial. Why would such immense effort and skill be expended on a space meant to remain unseen, buried forever in the earth? Renowned archaeologists like Zahi Hawass have led excavations into these depths, uncovering structures that are technically brilliant yet functionally mysterious. The precision here is not merely decorative, it is fundamental to the space's integrity, keeping groundwater at bay and ensuring the chambers would endure for millennia. This continuity of skill is the most compelling clue. The hands that shaped the hidden foundation stones of the Osirian and the granite boxes of the Serapeum seem to be the same hands at work here, deep below the feet of the Great Sphinx. It suggests that the mastery displayed in the sunlight was merely the surface expression of a far more profound underground endeavor. Were these chambers ritual spaces for the ultimate mysteries of life and death, or could they have served a more practical yet equally advanced purpose that we have yet to comprehend? The very existence of this subterranean world confirms that our understanding of Giza is still only skin deep. For every answer the sands have given up, a dozen new questions wait in the darkness, reminding us that the greatest secrets may still be buried, patiently awaiting the touch of modern technology to finally reveal their truth. Our modern tools are finally giving us the eyes to see what our hands could never feel. High-resolution laser scanners now map ancient stone surfaces down to a fraction of a millimeter, revealing a hidden world of microengineering. On the seemingly flat faces of Inca polygonal blocks, these scans detect subtle, intentional undulations. The stones do not just meet at the edges, they press together across their entire surfaces in a complex, full-contact embrace. This invisible perfection explains the legendary seismic resilience, distributing stress across the entire wall as a single, unified mass. It is a level of craftsmanship so refined it was literally imperceptible until now. Ground-penetrating radar peers into the earth without lifting a single shovel, uncovering the deep foundations of sites like the Giza Plateau. It shows us that the precision we admire above ground extends far below, revealing hidden chambers and structural countermeasures that have stabilized these monuments for millennia. We can even analyze the stone itself. Isotopic analysis acts as a geological fingerprint, tracing the origin of a block to its specific quarry. This has proven that the massive stones of Baalbek were dragged from a site nearly a mile away, confirming the staggering scale of the logistical challenge. These non-invasive technologies allow us to reverse engineer the past. By creating perfect digital models, we can run endless simulations, testing theories of lever systems, ramp angles, and acoustic softening in a virtual world. We can model the flow of a geopolymer slurry or the stress points on a multi-ton block being transported. So, after all this technological empowerment, how close are we to truly cracking the code? The answer is both exciting and humbling. We are closer than ever to understanding the what and the where, but the how often remains just out of reach. We can see the micro fits in the Inca walls, but we still cannot replicate the social organization and the tactile skill that produced them. We can identify the quarry, but the mental blueprint for moving 1,000-ton block still eludes us. Modern science has not diminished the mystery, it has deepened it, framing the achievements of these ancient cultures in even more brilliant relief. This fusion of silicon and stone is our greatest hope, offering a path to finally listen to the whispers trapped in the rock for thousands of years. From the towering walls of Sacsayhuaman to the sunken citadel of Yonaguni, these stones form a global puzzle. They are not merely ruins, but a persistent question carved in granite and limestone, challenging the very timeline of human achievement. We have explored theories of lost tools, forgotten chemistry, and even the manipulation of sound itself. Yet the core mystery endures, a testament to the breathtaking ingenuity of our ancestors and the sobering limits of our own understanding. Perhaps the true secret was not a single piece of advanced technology, but a confluence of factors we struggle to reassemble. A deep cultural drive for perfection fused with a generational mastery of material and geometry. These civilizations, whether working in isolation or inspired by a common, forgotten source, achieved what we would call impossible with the tools we have assigned to them. Their legacy is a powerful reminder that history is not a simple, linear progression, but a story with missing chapters, peaks of knowledge that were reached and then lost to time, conquest, or cataclysm. This is not a call to embrace the fringe, but to expand the mainstream, to continue probing these ancient wonders with every tool at our disposal, from laser scanners to an open and curious mind. Each perfectly fitted joint is a story of a people who looked at a mountain and saw not an obstacle but a canvas. They urge us to preserve these sites, not as static monuments, but as active classrooms. The stones may be silent, but their message is clear, echoing through the ages and inviting every new generation to look closer, to question deeper, and to seek the truth. If this journey has sparked your curiosity, we would love to hear your thoughts in the comments. For more deep dives into history's greatest enigmas, be sure to subscribe. The conversation is just beginning.